de Broglie wavelength of electrons. The de Broglie wavelength of an electron is a fundamental concept in quantum mechanics introduced by the French physicist Louis de Broglie in 1924. It represents the wave-like behavior of the particles such as electrons that were traditionally thought to exhibit only particle-like properties. De Broglie proposed that just as light exhibits both particle and wave characteristics, matter, like electrons, also exhibits wave-like properties under certain conditions. The concept: if an electron is traveling with a velocity v, its momentum p equals m times v, where m is the mass of the electron, and the de Broglie wavelength is lambda equals h upon mv. Let an electron of mass m be accelerated through a potential difference of v, volt. The kinetic energy acquired by the electron is given by 1/2 mv square equals E times v. Therefore, the speed v of the electron is v equals square root of 2ev upon m. Hence, the de Broglie wavelength of matter wave associated with an electron is lambda equals h upon mv. Let us substitute the velocity v as square root of 2ev upon m. On simplifying, we get lambda equals h upon root of 2emv. Lambda equals h upon root of 2emv. Since the kinetic energy of the electron k equals E times v, then de Broglie wavelength associated with the electron can also be written as lambda equals h upon square root of 2m k. K is the kinetic energy of the electron. Substituting the known values in the above equation, h as 6.626 into 10 power minus 34 joule second, whereas the charge of the electron has 1.6 into 10 power minus 19 coulomb. Then the mass of the electron is 9.11 multiplied 10 power minus 31 kg. On simplifying, we get lambda equals 12.27 Armstrong upon root v. For calculation purpose, we can use this formula. Lambda equals 12.27 upon square root of v Armstrong. Example calculation. If an electron is accelerated through a potential difference of v equals 10,000 volt, then de Broglie wavelength is lambda equals 12.27 divided by root v Armstrong equals 12.27 divided by square root of 10,000 Armstrong equals 12.27 upon 100 Armstrong equals 0.1227 Armstrong is the wavelength of the electron. Lambda equals h upon square root of 2 times EMV. Conclusion. As the potential difference increases, the electron's velocity increases, leading to a smaller de Broglie wavelength.